Hello everyone, this is the video report for the part 1 of the Cloud Computing Capstone for the Cloud Computing Specialization in Coursera for the University of Illinois at Urbana-Champaign. My name is Herman Suarez and I would like to show you a little bit fast everything about this challenge. So the first part of that I'd like to show you is the ingesting and analyzing data for each question. Right. What was exactly what I did in this part? Well, as everyone, I have to mount to restore data storage with all the data. I use it using one EC2 instance, specifically this 2 micro instance. So I restore and backup everything because I was a little bit worried about running out of credits, Amazon credits. What I exactly did was start downloading every single file on all the aviation folder to my local folder. So as you can see here, I have basically all the data, all the aviation data from 1988 to 2008, and I started working locally on that. What was exactly what I did? Well, actually I started writing different Java programs, one for extracting and zipping every single file recursively, as you can see here. Well, so a main util that get a folder and start unzipping every single folder, creating a new folder for each year. And then after that, I create a CSV transformer. My primary idea with this was that I wanted to process locally and to make the data cleanse locally before uploading and start processing anything in Amazon Web Services. So basically, the way I use this transformer is that I take a root folder. In this case, the folder that is the parent folder for every single folder year, and start processing recursively each CSV file that it finds. And the idea of this was basically analyze what was needed for each of the questions in every group, and just filter the elements I needed. For instance, for question one was about to rank the top 10 most popular airports by number of flights. Exactly what I needed was the origin and destination. In this case, what I did was okay, take the origin and destination of read the origin, get the position of the origin and destination in the file, and start filtering by those columns, and just generate the file with those things. For example, in the group 3 question, I needed origin, destination, flight date, departure time, and arrival delay in minutes, and that generated something like this. For example, showing you the head of the file, you can see the region, destination, the date, the departure time, and the delay time. So I created these different files, and after I created those different files, I created a structure into a bucket. My bucket was my nickname, then Cloud-mooc, elastic map reduce, and then I created a folder for each question representing the group that it belongs and the question that it is, with the following structure. For example, as you can see here, well, all my development was in Java, so every single question has a jar that is the one that is used by Hadoop in order to process the different data, and I got the input, the logs, and the output of every single one. I will focus a little bit in the G3Q2 group 3 question 2 because I think it was the most challenged one and the most interesting one. So in this case, you can see here, these are the process file, quite similar to the ones I showed you. And okay, and this is the logs for the map reduce, and this is the output. So after that, we can see here I just cloned one of the elastic map reduce for that task. As you can see here, I use on my custom jar, indicating what was as an argument what was the input folder, the output folder. So indicating the number of instance, I decide to use medium instance in order to don't spend all my credit. I use one master and two core instances. And here you can see the logs. I also activated voguing. And also I use my instance key for doing everything. So I will create a cluster. That was the way I did. Well, it will take a little bit time while processing the things. The case is that while this is ready, I would like to show you the results that I also downloaded, because I think for the purpose of the video is a little bit faster doing this way. So I created a output folder. In this folder I got this, and this is basically the three results, the part 1, part 0, part 1, and part 2, that are the ones that are processed by the elastic map reduce. And the structure of my results, sorry again. So the structure of my results in this case was also a file separated by tabulations. Well, in this case, the first is the row. This is the key. Then I got for this specific case, that is group 3, question 2. I got the start, the initial date of the flight, the departure time, the delay, the second date for the second trip, this date and this delay. So I would like to show you a little bit of my code for that one, which is in this project. So for making the things clear, in this case, and most of the other projects, because I have to group and rank in top 10, I used two mappers and two reducers. For instance, let's take one. As you can see here, I got a mapper for the question 1, which going to take the origin destination, put it in a single, getting the origin or destination as a key, and add 1 for every single occurrence of that airport. Let's see it here. Just pretty easy code. Then taking the reducer, and for each airport counting and aggregating or summing or adding every single value, and then a mapper for getting the top 10 and reducer for filtering the top 10. Pretty the same as we use during the class in the examples. Actually, this code is based on that. For the last question, what I did was a little bit different. Okay, I split the every single line that I read from the file in the mapper. So I get the origin airport, destination airport, flight date, departure date, arrival delay, and then what I thought was, okay, the good way to do this is to take the destination, to take every single line, take the destination airport and the origin airport, and create 2 keys basically for every single line. One with the origin airport as a key, other with the destination airport. But not only the origin and destination airport, also I think it was important to have the flight date as a part of the key. But taking into account that I wanted for the origin airport to add the date with adding two dates. In that way, I could group the different. I could have as a join key one that could be an origin and destination at the same time, and that way trying to create the different routes. That was what I tried to do here. Obviously, I take into consideration the departure time in the mapper. So if the departure time was equals to 12, so I created both keys using origin and destination. If departure time was less than 12, I just created one key with the origin, and otherwise I create just one with the destination. And also I put the rest of the things as a data and differentiate if the key that I was using was an origin or was a destination. On the reducer side, what I did was group everything into different maps, depending if it was an original destination, adding to a map, and then recurring, iterating over the two maps, and start creating the outputs and write that output to the file. Then after that, and having all that data that was similar to this output, what I did was upload it to DynamoDB. I tried trying the pipeline, but it was a little bit hard, and I couldn't do it like that. So what I decided was downloading again from my S3 bucket. Well, here is provisioning, but what I did was try to download the output. In this case, the folder is empty because the MapReduce cluster is processing again. But I actually download what you see here. These three parts that were the output from Elastic MapReduce. I took that output and I created another project that was a Capstone DynamoDB, where it was a really basic project where I took the results, I read the folder, and for each file I created a new item with the road, first date, first departure time, second date, and the total delay, and the fields that you can see here, and storage everything in this DynamoDB as can be seen here. So here I have the different results with the road. The road was my partition key, so it is supposed to be the way the cluster, the way is going to be partition the cluster, and have an integer ID as a primary key. And I got the data here and can select the different data, and this was pretty the same for the other process. Okay, that was what I wanted to show. I took a little bit more of the 5 minutes that was suggested, but I think it was a little bit complicated. Just for saying, basically I was based in this this architecture where I put everything, all my input data in a bucket, read by the Elastic MapReduce. Then the output results were here, and after that I took the output results and processed them and storage in DynamoDB. Okay, thank you very much for your time, and hope you like this video. Goodbye.